Dear all, now in this small presentation, we'll see how polynomials can be represented using array concept. What do you mean by polynomial? Polynomial takes this type of representation where we can see the unknown x and its power, and this is called exponent, and a number which is attached to this, that is a coefficient. Just for the simplicity, we'll take coefficient as integers. One more point that you have to note, for the purpose of representation, all these polynomial terms should be in the ordered form. It can be in the descending order of powers, that is exponent, or ascending order of exponent. In this case, here we will take exponent terms are in the descending order of powers. Whatever may be the given polynomial, you arrange that in the descending order of exponent. The first term exponent is 3, second term exponent is 2, third term exponent is 1, fourth term exponent is 0. This 3 can be written as 3x power 0. 3, 2, 1, 0 are the exponent. The first term's coefficient is 2, second term's coefficient is 4, third term coefficient is 5, fourth term coefficient is 3. You can see all the exponents are arranged in the descending order. You can observe 3 is the highest power. That 3 is called degree of the polynomial. Highest exponent is the degree of the polynomial. What all operations we can perform? We can multiply polynomial. We can add the polynomial. Suppose A and B are the polynomial, that resultant can be represented like this. Suppose the first polynomial is 4x3 plus 2x, and second polynomial is 6x power 8 plus 3x plus say 3. Now we have to add them. You can add only if exponents are same. The first term of this is 3, but x cube is not there, x power 3 is not there, so just leave it. Next, this one 6x power 8, here it is not there, so that will go to resultant polynomial x power 8. This is over. Then the next smaller power is x cube, that is 4x cube. This is also attached. The next is 2x, corresponding single power is x. 3 plus 2 is 5x. You have to add them. Only you can add if their terms of the exponents are same. Then this is over 3. No constant term here on this side, that is 0. 3 plus 0 is 3. This is the result of after adding two polynomials. Okay. Now, how to multiply two polynomials? We'll take one more example. Let us take 4x cube plus 3x, first polynomial. Second polynomial x power 2 plus 5. Now we have to multiply these two. Multiply all the terms of the first one with all the terms of the second one. Now we'll start multiplying this term with this one. 4 into 6 is 24, x power 3, x power 2, x, that is x power 5. 24 x power 5. Exponent to be added, coefficient to be multiplied. This term with this one, 20 x cube plus this term with this one. 3 into 6 is 18 x cube plus 3 into 5 15 x. This is the result after multiplying to polynomial. While multiplying, multiply coefficients and the powers. You have to repeat it for all the terms. This is the result after multiplication. These two major operations you can perform. The next question comes. You can perform any operation only if it is represented in the memory. If the data sits in the memory, then you can perform the operations. We'll be taking the concept of structure. Let us take a polynomial is having the highest degree, that is 101. Can have this to the other values also. So that means that much of memory location has to be reserved. We are going to create a structure. The first field of that is degree. Second is coefficient of all the terms of exponent, like from highest exponent to the smallest one, that is polynomial. In this case, suppose my polynomial is 6x cube plus 1. In this case, how the polynomial is represented? If a polynomial is a, then the degree, highest degree, as these terms are arranged in the descending order of power, so highest degree is 3, a dot degree is 6, sorry, is 3. Then a dot coefficient, the first coefficient, second coefficient, like that you would repeat for all the things. That is a dot, 3 times you have to repeat. A dot coefficient of 3 is 6. A dot coefficient of 2, nothing is there, so 0. A dot coefficient of 1, that term is also not there, so 0. A dot coefficient of 0 term, 0 term is there, that is 1. As you can see, there is a wastage of memory. Even for 0, exponent 0 also you have to store the things. Suppose this term is around, say, 30. This is 30. The degree of the volume is 30, and this coefficient of 30 is 6. Then all these are 0. It's a wastage of memory. This particular representation may not be useful if the number of terms are missing. So that leads to wastage of memory. So what is the solution? So you have to alter this concept of storing. Uh, Before taking it, I'll show you the diagrammatic representation of this one. We'll take 30 only. That means how much space you have to reserve? 30 plus 1. 31 place you have to reserve. Like this. I'm able to represent this because it's a memory. Like that, a dot degree is 30. This coefficient is 6. F 36. 0, 0, 0, 0, dot dot dot. The last term value is 1. This is the term. So this much space is wasted in this representation. The solution for that is this one. We'll we'll be declaring a polynomial. Instead of storing all the things, here we'll be storing the terms which exist in the polynomial, coefficient and exponent part. Now, let us take two polynomial, A polynomial and P polynomial. In this case, you go on represent all the terms. The first term is 2x power 10. 2 is the coefficient part, and 1000 and 100 is the exponent part. Any more terms left? Yes. Second term, coefficient is 1, exponent is 0. That finishes the first one. Here you can have two pointers, which is the starting point of the polynomial and which is the end point of the polynomial. Start point of the polynomial is represented using a pointer called start A. Last part of the polynomial is represented using finish A. So this quite simpler and useful representation where this eliminates the wastage of memory. Now we'll go for the second one. X power plus 10x cube plus 3x square plus 1. The first term x4, exponent is 4, coefficient is 1. Exponent is 3, coefficient is 10. Exponent is 2, coefficient is 3. Exponent is 0, coefficient is 1. So next place is available. This can be utilized to store the sum or product of two polynomial. We will be seeing this in the next example. This is the second polynomial things. Here it maintains arrays of coefficient and exponent structure. This representation quite useful. With that, you can represent any polynomial, avoids wastage of memory. Now, when you are using any programming language, what are all different operations we can perform on a polynomial? The first is you're going to return a polynomial term 0. You're resetting, like when two polynomials are given, you want to store the sum of two polynomial or product of two polynomial. You will be starting with the 0, nothing, no term in the polynomial. That can be obtained using a function called 0. This is a ADT only. When you are taking any programming language, you have to write the code. This is just general code only. This particular polynomial returns a polynomial with 0 number of terms. Degree of this polynomial is 0. This is the way. Returns a polynomial of degree 0. Next, I just wanted to know whether that particular polynomial is 0 or not. This returns true if so, otherwise returns false. For that function is 0. Like in this example, is polynomial is 0 in this case. Is polynomial is 0, returns 0 because it is not a 0 polynomial term. It's having two terms. In the same way, is polynomial b is 0, it also returns 0 because that's a term. That is about is 0. Next, for a given exponent, I wanted to know its coefficient. So two parameters you have to pass. One is the polynomial, other one is the exponent. For example, I'm using the function coefficient. I'm returning the coefficient. It returns 0, otherwise the term, otherwise that exponent part. Take a polynomial and term is 2. What is the coefficient? Coefficient of that, the answer returned is 8 because 2 exponent and its corresponding coefficient is 8. Next, leading exponent, which is the highest one, highest degree. With that, we can get the degree of the polynomial. Let us take the first one. As the terms are arranged in descending order, highest term, leading term is 2. Its coefficient is 8. The leading term exponent is 2. The degree of the polynomial is 2. In the second case, terms are arranged. Highest itself is 6. That is 1. The degree of polynomial is 1. In this case, if you're using for b, you will get 1. If you're using it for a, you will get 2. That is the degree of the polynomial. Now I have to attach, because after adding or multiplication, that result will go to the terms that is generated will go to the result. For that, we need this, where you're going to attach the polynomial. What term you are going to attach? The term is having two parts. One is coefficient part, other one is the exponent part. For example, for a I have to attach one more term, that is power 3. The exponent is 3 and the coefficient is 1. So that becomes like this: 8x square plus 3x plus 2. After attaching this particular term to a, say that result is C. C is 8x square, existing one, 3x, the new one, 2x power 0, old one. This is attached. Now, in some cases, I have to remove that. I don't want that polynomial. How to remove? Again, polynomial is required, which is the exponent. That term can be removed. Like in the previous case, this is my polynomial. I have to return, I have to remove the exponent, that is 2. This can be removed. Uh, 8x square is the term, 2 is this one, so that can be written. This is the answer. Purpose of this remove is to remove a term having exponent 2 and returns that new result. C is the one term that is removed from C. Next, multiply. You can multiply two polynomial, and you can multiply a particular term to that one. As explained in the previous case, particular term you're going to multiply to a polynomial. For example, I have to multiply a term 2x power 1 to d. The answer will be 6x into 2x1, that is 6x square plus 4x plus uh, 2 into this one. 2, 3 into 2 is 6. This one, this I will explain here. You are going to multiply d is 3x square, sorry, 3x plus 2. Term that you are multiplying is 2x power 1. Term that you are multiplying is 2x power 1. 3 into 2, all the terms you have to multiply. 3 into 2 is 6, 6x square. 2 into 2 is 4. This is how to multiply. In the same way, two polynomial can be added, two polynomial can be multiplied. Result returns the result. For example, d and e to be added and returns f. D and e. This is e. This is g. So 6a square plus 4 plus 3, 7x plus 2. These two after adding. In the same way, these two can be multiplied also. Answer will be 6 into D and E can be multiplied. 6 into 3, sorry, here A and B multiplied. A and B multiplied. 6 into 4, 48 x cube plus 6 into 2, 12x. These two are multiplied. That gives answer F. 6 into 4, 6 into 8, 48. X into x square, x cube. 6 into 2, 12. And x. This is the answer. These are ADTs. Any when you are using any programming language, you can implement it. Now we'll see how two polynomial can be added. Let us take A as one polynomial, B as another polynomial. We want D polynomial. Initially D is 0. I want nothing in that polynomial D. So d equal to 0, that 0 function can be called. This is all just a general routine. When you are implementing with a slight modification, you can do that. Here, the function 0 will returns nothing. Next, is not 0, not is 0. That is, A term is not 0, B term is not 0. You can see that A is not 0 and B is not 0. Proceed. For example, to add that I told earlier, let us take again one example, 6x square plus 8. Other term is 13x cube plus x. These are the two polynomial to be added. Is A 0? This is A and this is B. D is nothing right now. D nothing. No polynomial is there. No term is there. I have to add these two. Is A is 0? No. Is B is 0? No. Then Compare leading term of first one, leading term of the second one. The leading term is 2 and leading term of the B is 3. Compare them. 2 and 3 are compared. When compared, answer possibilities are of three types. It can be 0, it can be higher, or it can be lower. In case when you compare, the leading term of A, leading term of B returns value -1. That means B is having higher term than the A. That means A, only B term you have to attach it. Now, what is the leading term of this one? Leading term of B, that coefficient part 13, leading term itself, that is 3, you attach to D. D is nothing. So after attaching, the answer will be 13x cube. So you don't want this one. So you have to remove it. Further consideration not required. So remove it. Repeat this step. Again, A is it 0 or B is it 0? No. Leading term of A and leading term of B are compared. Leading term of A is 2, leading term of B is 1. 2 and 1 are compared. 2 is bigger than 1, returns 1. That means which term you have to attach? In this case, A terms you have to attach. A term, not the complete thing, the leading term. Extract the leading term. How to extract? Leading term of A, its coefficient part, leading term itself, that is 2. Attach that to D. So after attaching, the answer will be 6x square. Okay. Now, this no need to consider, remove the term. Repeat this step. Leading term of 8, leading term of A, leading term of B to be considered now. Compare them. Leading term of A is 0, leading term of B is 1. 0 and 1 minus. So which term to be attached? The highest one, that is B. The answer will be X. Remove this one. Here we don't have any more term like compare the is A 0? No. Is B 0? Yes. That means we have considered all the terms of B, but only one term is there in 8. What to do? In such cases, any remaining term of A or B to be inserted. Remaining term in the A is 8, insert that one. No more term in B, insert all the terms of 8. Just a repeated remove operation, you can extract and you can add it. This is how the first version of the polynomial looks like. Like for attachment, what is required? The coefficient of term to be added and exponent of the term to be added. For example, if D is 0, for that, what is required? So in the next place, in the next memory location, you are going to add the term to be added. If suppose 6 square x square is required to be added, that structure looks like, suppose these are all the things already occupied. In the next available space, coefficient 6 to be added and exponent 2 to be added. This is how. In the next place, you go for exponent and this one. After that, keep it ready for the next element. That is why avoil plus 1. Note that avoil plus 1 to be added here. Otherwise, separately you can write it. Avoil plus plus. But for both, don't put it. The coefficient is 2. 2. One more, suppose now I have to add 7 to this one. Term coefficient is 7. Term exponent is 0. Keep it ready for the next one. Avoil plus plus. This is how the terms can be added. Now, the second version of polynomial addition, how that goes. We'll take example like 6x square plus 3, 8x cube plus 3x square These are the two terms, two polynomial to be added. The function name is polynomial addition. How this is represented in the memory, we'll take that also. A structure array having two fields. First, starting point of A. All the terms are arranged in the descending order of exponent 6 to next term. This is the starting point of A. Alright, SA, starting point of A. Second term is 3, 0. This is for the timing, alright, end point of A. Similarly, the second polynomial, coefficient is 8, term is 3, coefficient is 3, term is 2. This is the starting point of B. This is end point of B, then nothing. This is avail. Right now, avail is the A. Avail, AVAIL. It is pointing to next free location. So to perform addition, we need to send all the things. Starting point of A, finish point of A, starting point of B, finish point of B, a pointer to next new polynomial D. So that is pointing to avail. Our new polynomial starts from here, that is start of D and finish of D or end of D at the same place. This is what that sentence means. Similarly, you compare them. Whether starting is reached to the end point. Right now, no, because there are two terms. Starting point is here for A, end point is here. They are not in the same place. In the same way, you compare whether starting point of B is reached to the end point of B. No, both did not reach. Compare compare the exponent of A and exponent of B. Starting point of A exponent part is 2. Starting point of B exponent is 3. 2 and 3 are compared. 2 and 3 are compared. 2 is smaller than 3, returns -1. In that case box, this part is compared. Now, what to be attached? They are not same. That means you cannot add them. So one of the term has to be added. Which term? The highest one. Is it A or B? Highest is B. So that 8 and 3 will go to the resultant. You can see that after adding these two, this is the first term, 8x cube. I'll write it here also, 8x cube. Okay. Now to attach this, where to attach? In the available place you have to attach it. That seen just before. What are the terms to be added? The only one term to be added. What is its exponent? That is terms starting point, that is coefficient part 8, 8 and exponent part 3. 8 and 3 to be placed here. In the term array, starting point of B its coefficient part, starting point of B its exponent part. Coefficient part is 8, exponent part is 3. Attached. After that, as we have considered this one, you have to move by one place. Now starting point of B will come here. That is why the line start B. Compare again. Now we are here. We are here. Whether it is crossing? No. Compare this term, the first one, and this term, the second of the polynomial. Second polynomial. Are they same? Yes, they are same. Now what to do? Add them. Coefficient, new coefficient is A's coefficient and B's coefficient to be added. of the same degree, that is 2. 6 plus 3, 11. 6 plus 3, that is 11. That 11 should come here. Attach coefficient of anyone, coefficient that newly got coefficient, and which term, it can be a or it can be b, anything is okay. What is the result? 6 plus 3 is 6 plus 3, that is 9. Any one term, you can use a or you can use b's also. You can use a or you can use b, anything is okay. Having done this one, you have to advance by one place. That starting point of A now moves to here, and end point, the starting point earlier it was here, now it goes to next. So here this condition fails. It is not. It is not in that finish point. It is crossing in case of B. That means you considered all the terms of B. That is the meaning, but only one term is left. So the case will fail, the while will fail. Remaining terms in A or B you have to add it. Anyway, B part everything is over. Remaining term, right now we are here. Right now we are here. You have to move till the finishing part. You move till finishing part. This is the line that will take you to the end of that one. Extract each and every term of A or B. In this case it is A. Attach it. Attach terms, coefficient part in that, that is 3, exponent part in that, that is 0. You attach it. The answer will be 3, 0. The final answer will be 8x cube, yes, 9x square, x, 9x square, x, the last is 30s. So this is the result of polynomial addition. Have a look this again. Thank you.